I think this really sets the stage now for entering a bit more detailed exchange on what we see as use cases and requirements for this new or this next generation of communication technology. And to that effect, I would like to invite now Mr. Hao-Won Lee, who's professor at Hanyang National University, to give us his presentation on the vision and use cases for 6G. Thank you very much.
Good afternoon. I'm Professor Hao-Won Lee from Hanyang National University. I'm also serving as Vice Chair of 6GPF in 5G Forum Korea. The title of my talk is Towards 6G, Vision and Use Cases. On behalf of the 5G Forum and our member companies, I'm honored to share the 6G vision and use cases from the 5G Forum's perspectives. Also, this talk contains what I think about 6G as well. First of all, I'm very sorry that I cannot attend until the end of this workshop because I have to go for the evaluation of the graduation project of my students. I'm sorry about that. If you have any questions, please send me an email, hwle@hknu.ac.kr. Okay. The outline of my talk is like this. In this talk, I'd like to talk about 3 drivers of 6G and the challenges and use cases of 6G, and I'll conclude my talk. This slide shows an introduction to the 3 drivers for 6G. We can think of 3 drivers for the successful development of 6G in South Korea. They are the policy lead by the government, technology push from the research, and need pull from society. I think that 3 of them will equally matter in 6G. Like other generations of mobile communications, the Korean government makes plans and executes them to take the lead in the global 6G competition. Technology itself drives the development of new products and services by improving performance. In the digital transformation era, many societal problems are issued and expected to be solved by ICT in the future. The societal requirement pulls the development of technologies as we move forward. These 3 drivers would move and play a complementary role to each other for the 6G promotion. Recently, we have 2 representative strategies going on. The Korean New Deal responds to social requirements, and the 6G R&D strategy boosts up the technology advancement. We will have a better chance of promoting technological advancement through policy leadership, meeting the demands of society, and solving various societal challenges by technology and policy in 6G. In this talk, this slide explains policy lead, but because of the limited time, I will skip this slide. Second one is tech push. We expect a 6G life where humans and many highly autonomous and intelligent machines live together in the physical space and digital twin space. The first key aspect of physical space is a truly immersive service, connecting real experiences to humans, including advanced tactile. The second aspect is that autonomous machines interact with humans ultra precisely and fast. These are the two key aspects of the physical world. There would be a digital world enabling the physical world. This digital world should be ultra reliable to ensure all the physical world requirements. The digital world should also be capable of communication and ultra computation to make sure ultra autonomy in the physical world. Trustworthiness is also a key requirement. 6G will come into play to connect these physical and digital twin worlds. From the network perspective, we can bring up two key aspects. One is the expanded service coverage for all the humans and machines around the world. The other is native AI for all the services, devices, and infrastructure. 6G will be connecting intelligence over the expanded coverage in the physical world. And it will also bring on the open network architecture in the digital world. Combining the digital and physical world, 6G senses vast amount of data exceedingly fast, computes them, controls, and offers the experience to humans. Yeah. This slide also explains about tech push. We can break 6G technologies into 4 groups. Yeah. First one is the expanded coverage with the non-cellular topologies. It includes satellite, airborne, and UAV. It will offer an expanded range and enhanced mobility to make sure the improved connectivity and service continuity. Also, new spectrum and the antenna technologies will be one of the key revolutions in the next generation. The sensing and communication in terahertz range, metamaterial and intelligent reflecting surface. They are good candidates for ultra reliable communication. Also, free space optics and line of sight MIMO can be candidates too. Sensing information about localization and propagation can revolutionize medium access technology. Yeah. Third one is the native AI for connecting intelligence. When the mobile unit senses and collects data, the data will be split for computing for on-device or on cloud. And then it flows into networks and mobile edge computing. Mobile edge computing, MSP. Comprehensive AI allows an automated real-time optimization of resource allocation from the mobile sensor to MEC. Yeah. Last but least is the new radio access technology. We can think of 3 key Third service scenarios in 6G, they are ultra broadband, zero energy, massive IoT, and massive broadband URLC. Especially, we expect a growing demand for this massive broadband URLC with minimum energy consumption in a 6G world. Developing new access technologies such as channel coding, modulation, multiple access, waveforms, and full duplex is another big challenge for 6G. Low complexity, low processing delay, and low power consumption are could be other goals. Yep. Now, let's move on to the needful third one. This is from the societal challenges in South Korea. I'd like to take a look at the issues in each societal area. We defined 6 societal areas by analyzing various future forecasting reports published in South Korea. They are education, health and welfare, labor, transportation, culture and art, and safety. Also, we specified each social issue in terms of individual, households, city, and country. We also include issues on the extended cyberspace, including physical and digital world. In education, inequality happens from an individual's perspective, leading to wider income polarization. So the education disparity gaps between regions are getting deeper from a national perspective. In health and welfare, Korea is one of the most aging countries in the world. So there has been a growing concern about elderly care and low birth rate in society. In labor, as the fourth industrial transformation moves ahead, there is also a growing concern of employment instability. Depending on where you live, depending on individual health and financial capability, they are given limited transportation options. There is a demand for reducing regional disparity of consuming cultural contents across the nation. Lastly, COVID-19 issued a growing demand for safety in various levels of a person, household, city, and country. Yeah. In this slide, I'd like to introduce 3 challenges facing 6G. Yep. First, the service domain of mobile communication systems is gradually and rapidly spreading. In my opinion, 5G attempted to create a synergistic effect through convergence with various industry verticals, and such as extended reality service, autonomous driving car, smart factory, smart city, and so on. The effect and growth is expected to exponentially increase in 6G. I hope so. Especially exponentially increasing uplink mobile traffic generated by these convergence services should be reliably supported by the forthcoming 6G networks. Second, three-dimensional network coverage should be considered in 6G. Yeah. Since the 4G LTE and 5G NL systems designed for supporting ground user services, they still have several problems in serving various kinds of drones flying over an altitude of 150 meter to 10 kilometer and high-speed ground vehicles with a speed of 500 kilometers per hour or more. Recently, the demands for the use of these drones and high-speed ground vehicles are exponentially increasing. And it is also expected that the global market for aerial vehicles, aerial mobility, such as flying taxi, military UAV, smart airlines will grow significantly. Moreover, in 5G, it is still hard to provide reliable and seamless communication services in shadow areas. This is a very important point, I think, such as desert, ocean, island, and mountain areas where installation of base stations and relays is impossible due to physical limitations. In this regard, space, air, ground integrated networks can be one of the key solutions to resolve the problem of the shadow areas. However, to realize the space, air, ground integrated networks, we should consider new features which have not been considered seriously yet before. These include extremely long propagation delays, large Doppler shift, and super large cell size. Yeah. Third, a seamless and reliable connection between the physical world and the digital world will become one of the important features to realize digital replica. Sometimes we call that digital twin. When applying AI algorithm to solve various social problems in physical world, it is very difficult to find out the effects of applying the algorithm directly to the real physical world. In this aspect, the application of the AI algorithm is relatively easy in the digital world implemented through digital replicas. Okay, next. I will show you 4 use cases we discussed together at the 5G forum. Yeah, I will briefly introduce these 4 use cases. The first use case is the Internet of Experience. All the names of all use cases are new. Yeah, in the social aspect, we can think of equal opportunity education through 6G and immersive media services. Second use case is augmented human. 6G can help to provide augmented health and augmented intelligence to humans. The third use case is sustainable automation. Yep, you can imagine smart factory, something like that. Yeah, especially in smart factories, wirelessly networked robots can be very helpful for maximizing production efficiency. In this case, energy efficient operation is also very important to maximize the lifetime of the robots as well. Last one is an embedded AI service. Embedded AI engines always need appropriate data corresponding to the current situation, like context-aware service. So 6G networks should provide this information on time. Sorry. Okay, let's move on next to slide. Yeah, okay. I will show you challenges and use cases of 6G. But it's a little difficult, different from the 5G forums one. Yeah, I'll talk about the 6G use cases that I think of. Yeah, including the 6G use cases of the 5G forum. As I mentioned before, 6G should provide global three-dimensional network connectivity. Low Earth orbit LEO satellites can extend network coverage even to sky, ocean, and desert areas. Also, HAPS can take the role of data bridge from satellite to terrestrial networks or terrestrial networks to satellites. Because the number of drones, such as flying taxi, as I mentioned before, military UAV, and smart airlines is expected to increasing exponentially. 6G should provide seamless connectivity for all aerial vehicles. Final 6G network will be denser compared to 5G networks. Over the past few years, there has been a rapid increase in the number of base stations to support the massive amount of mobile data traffic and vastly increasing number of mobile users and devices. Also, due to the emergence of various services based on the convergence of cellular networks and industry verticals, ultra-dense networks, UDN, based on small cells have been actively investigated to support the requirements of these services. Yeah. To support immense and volumetric visual user experiences through XR, digital replica, and metaverse services, the immense frequency bandwidth of up to several terabps will be required in 6G. That is to support 1,000 times higher spectral and energy efficiency. 6G requires far larger frequency bandwidth, which motivates the uses of new frequency bands such as terahertz band. Due to the propagation characteristics of terahertz band, the 6G cells are expected to become very tiny beyond small and femtocells. There is a very large propagation loss at the terahertz band caused by path loss, molecular absorption, and atmospheric attenuation, leading to severe coverage limitations. Also, it causes a frequent and unpredictable coverage host due to the pronounced shadowing. This is I think very severe problem in 6G. Yeah. The second one is digital replica. Digital replica have to efficiently perform real-world management and problem detection and problem mitigation without human presence or detailed oversight. 6G will allow for the creation of digital replicas, and all these digital twins can be connected to the real world, real physical world through 6G. I hope 6G with advanced sensors and actuators and AI engines will accurately recreate real physical world entities into a digital sphere. Digital world can be realized and visualized through a virtual world like avatar or holographic projection. Third use case is a sustainable and safe 6G society. The 6G networks should offer all-inclusive connectivity meeting all societal needs. The word inclusion in the all-inclusive connectivity contains various meanings. Let me briefly add a bit on that. First, the 6G will expand the verticals of 5G to the societal areas. Its coverage will reach beyond the terrestrial scope. Indeed, its connectivity should also reach everyone. Lastly, its connectivity is for the future of sustainability of humanity. So 6G all-inclusive connectivity will solve many problems existing in society. 6G will contribute to resolving various societal challenges I mentioned before in education, labor, health, transportation, culture, and safety areas. For example, 6G will have to bridge the medical and educational gap between classes through low latency immersive media services. Last use case I will show you. The fourth use case is truly immersive media. 6G makes humans interact with projected 3D images in real time, even projected holographic images. Also, right side figure, 6DOF, Degree of Freedom XL can provide full immersion, and humans can become a part of the story, not the audience. 6DOF XL can detect rotational movement and translational movement of users. So they can move in the virtual world like they move in the real world. Yeah. Okay. Yeah. This is conclusion. From a societal point of view, an industrial point of view, and a technical point of view, I hope 6G will contribute in many societal and industrial areas. Thank you. This is the end of my presentation.
Thank you very much for this presentation and for the very interesting illustrations of 6G applications. I would now like to call Mr. Sungo Choi, who's project manager at the Institute of Information and Communication Technology Planning and Evaluation, to present the strategy and roadmap towards 6G. Mr. Choi, the floor is yours.
Thank you, Javier. Okay, let me introduce myself a little more. I am a program manager, not project manager, for telecommunication R&D planning and evaluation, working for MSIT. I was a Samsung standard engineer for 20 years, and I joined the government members from 2 years ago. So I'm very glad to see Luis Romero. He was my old friend. I'm very happy to see him today. So today I wanted to share what is the 6G R&D strategy from our government point of view. My slide has around 20 slides, but I will make it very short. Firstly, I want to share what Korea had a successful story for 5G, because this is very well understandable story, and it is very related to future 6G roadmap and efforts. So I will briefly share with it, and I will share what 6G technology directions and expected 6G schedule. This will be very general our understanding in Korea, and chapter 4 and 5, 6 will show what is a Korean R&D 6G R&D plans and our views. So for the 5G, we had 4 phases. The first step was R&D, which we starting from this year for 6G, but for 5G case we started R&D efforts from 2013, and the government efforts. Sorry, I should move on. Okay, the first phase was R&D 5G R&D that was started in 2013. That was year what Korean government project started, and as well as Samsung projects started. So it has long around 5 or 6 years R&D was continued from 2013. It was very successful. We focused on millimeter wave technology as a really great candidate for 5G technologies. After that, as of phase 2, frequency standard efforts is very important, because 5G need new spectrum band, because 4G spectrum band already clouded. So I2R and WRC was very important standard entities to find out new spectrum. Global collaboration was successful. We secured new spectrum band for 5G. There was take a long steps, but finally we could successfully had that. And after that, we had 5G standard efforts with multiple countries, multiple companies collaboration. There was also long efforts from 2013, start with I2R efforts, and 2015 was the year 3PP start study item. And 2016, I remember Korea hosted the 5G meeting in Korea as a starting 6G standard meeting. And 2018, Korea again hosted the last meeting for 5G standard to finalize 5G standard. After that, finally, Korea successfully make the commercialization. That was also very busy days. 2018, you remember Pyeongchang Olympic, we show what we achieved until then. And 2018, earliest Korean government declared 5G commercialization plan. And then finally, 2018, end of the 18, we could launch the world's first 5G wave, and finally commercialization was successfully done in 2019. What I want to show that is it was started by R&D, earliest 2013. That was LTE just started as a commercialization, and 5G R&D and standard all efforts started at the time. That means this year, 2021, will be the very important time for preparation 6G. And during that long journey, sorry, next slide. Okay. Okay, so collaboration, global collaboration was very key. In Korea, we have 5G forum to work with European entities and also other countries' parties. And also government point for spectrum global standard efforts, we had a 28 gigahertz initiative working with America and China and also Europe. That all collaboration was very important to make us succeed in 5G. That require for 6G also. That's why I think we are here today. So let me move to the 6G topics. I like this slide because it shows all big pictures and we can expect what 6G we can do. Everybody knows the first generation and second generation is mainly for voice services. But you remember first generation introduced voice service, but it was not that successful. But second generation provide digitalized services that make voice service globally successful. And third generation introduced data service using the mobile. But fourth generation provide very innovative technology with OFDM and MIMO, make data service with mobile was successful. And 5G is a very important generation to introduce new service, which is called as a B2B or vertical. So mobile telecommunication will merge with other industry services. That is very challenging and very important. And I believe 6G will make that vertical service is successful by providing good technology solution. Then what we need to do for the vertical service successful in 6G area is very important topic we need to discuss today. So service, I don't think 6G service will be very difficult from 5G because 5G vision and service expectation is very high. So all services expected by 5G will be continued to 6G, but also very smoothly and very efficiently will be provided by 6G. So I don't want to mention that much on detail on the services, but then what we can expect as of 6G technology is we can achieve that point from considering what is the limitation of 5G technology. As you know, we expected 20 gigabps as a peak data rate for 5G, but if we expected all the applications in the future, the 20 gigabps will not be enough because one autonomous vehicle will require more than 5 gigabps in the street. If there are multiple cars in the street serving as autonomous, then 20 gigabps will not be enough. That means we need more data rate, more maximum speed. And also end-to-end delay is not really provided by 5G. We focused on radio delay to reduce the 1 millisecond, but end-to-end delay is very critical for remote control or remote access. So 6G should solve these key topics. And coverage, previous speakers say coverage will be enlarged in 6G area because in the future, flying car and drones, and more coverage is required to support those services. And AI convergence with multiple area, including telecommunication, will be expected 6G will perform on that. So this 4 angle is not that all the list, but Korean government think this is very critical, very important topic. So we wanted to focus on that, but also as European members said, energy efficiency and other people say localization, and all those things should be a key technology as considered as 6G. But I want to say these 4 topics will be the main focal point in Korean R&D at the beginning. So this slide shows what is the performance key indicator. So as you know, 5G we had 3, but 6G we think a little bit more. So ultra performance to show the highest speed, and also ultra bandwidth to support the highest speed. So we believe more than above 100 gigahertz spectrum band will be required to support those speed. And then ultra precisions, it will be about end-to-end low delay, and there's ultra space, considering satellite communication merging with telecommunication is the key topics for that, and also ultra intelligence with AI-based services. So I believe everybody share this view, and also this slide shows what 6G technology will cover. Everybody knows wireless communication is key as a mobile industry, but another angle is RF technology is very important to support higher frequency band. So it should be focused on while we are doing the R&D. And optical communication is also very critical, because wireless communication will support more than 100 gigabps and even 1 terabps. Then optical communication will be can be the bottleneck at that time. So speed up the optical communication also very critical. So we believe that is the part of the 6G technology development angle. And wired communication end-to-end delay reduction is another one. But lastly, satellite communication, Korean government, Korean parties think this satellite communication should be considered as a part of the 6G technology development. So this is about schedule. Previous speaker said ITU schedule and also 3PP schedule a little bit. So I wanted to compare what we did in 5G. The above schedule is what we know as a 5G schedule. If we consider similarly to 5G, 6G 2021, this year we start already in ITU the vision development. And I believe 2023 and 2024 will be requirement development in ITR. Then 2028 or 2029 will be the finalization of 6G standard. And based on those schedule for 6G in ITR, 3PP standard will be start at 2024 with a study item. As we did in 5G, when ITU are consider the requirements, 3PP standard members studied the requirement standard in 3PP, and following with the requirement consideration, study item started 2016. So because new generation standard require long period for study item, long period for work item. That means we believe 2024 will be the starting date for 6G technology development schedule. If we consider both 6G ITR schedule and 3PP schedule, this is what we expected. but it's up to industry, up to government. We can speed up the schedule for 6G, or a little bit we can have more time to finalize well-developed technology. So this is a very not decided schedule, but estimated by based on the 5G schedule. I believe end of 2027 or middle of 2028 will be the first 6G standard complete date. So we should prepare that schedule for commercialization for 6G. So based on those evaluation, Korean government last year we provide vision and strategy. In the today's keynote speech, Director Seol Jae-jin in the previous speaker shared what we are doing this year based on this vision announcement. But we announced this vision and strategy last year by saying leading 6G era imagination into reality as a vision. And we had three strategy. One is next generation technology development and standard patent related efforts, and thirdly infrastructure preparation. I wanted to share those three strategy a little bit detail. The first strategy is about preemptively securing world best 6G technology beyond 5G. As I mentioned the previous slide, 6G technology has required key performance index. So to support that, Korean government will started already from this year R&D investment. So we will work on to achieve 1 Tbps transmission speed, and also around 5 millisecond end-to-end delay latency, and also service expansion to support up to 10 kilometers above from the ground. That will be supported by ground telecommunication technology and also satellite communication technology. And also AI technology to entire network, wireline network and wireless network. That R&D is very challenging, but we started those technology development this year. And also security by design embedded from the ground. That is also very important because 5G had security issues from the commercialization. So we wanted to have a very secure design for 6G system from the beginning. So to achieve those results, global collaboration is very important. So one of the key partner, European parties, is very important. So I wish today we can share and also discuss what can we work together to make 6G R&D and also commercialization successful in the future. So next slide is about what is our strategy second to make a standard successful and a standard patent be secured. So government will provide support for global standard effort in private sectors, and also public sector will do efforts in ITU standard. And global standard leadership we are supporting, as Director Seol mentioned earlier. Today, we are very happy to see leadership in the ITU and 3PP in Korea member. And also we are supporting R&D, securing this patent. So third strategy is about layering a firm foundation for research and industries through localized core part and equipment and qualified workforce. So all efforts, we believe Korean industry to support multiple equipment and components in the communication equipments and also mobile. We had a good companies developing those technology in Korea, so government will support their R&D and support their collaboration with other countries' business and R&D. So that efforts be part of the 6G R&D planning. So as a last slide, I wanted to say that the 6G is not clear yet because all different views and different efforts will be harmonized, and the clear picture for 6G will be a little bit later cleared. So during those periods, our government wanted to have a very flexible planning and also approaching the 6G. So we make a strategy committee led by our government, with working with private sectors and also government sectors. So we will have a regular meetings to check the 6G R&D status and also global progress. So our government will have a kind of rolling plan update to adapt our plans to make a progress in the 6G R&D and to approach the 6G standard and collaboration. So I want to conclude this presentation. I wish today's workshop be successful to find out what Korean and European parties to work together to make 6G successful. So thank you very much.
Thank you very much, Mr. Choi, for this very informative presentation, and especially the interesting comparison between the 5G timeline and the projected 6G timeline.